good morning, or afternoon, depending on where you're watching this, or good evening. So, Miss Smoot here. So, do you guys remember when we talked?
I think that you should leave.
What? I'm just joking around because of what we talked about yesterday.
Yesterday? I've never even met you.
About the DNA code, how there's A, T, C's, and G's. You have basically A goes with T, C goes with G, and this DNA code is a double helix that's twisted. And basically, you use a DNA code for transcription of RNA, mRNA, and then from there, mRNA leaves and then makes proteins, right? Well, we know sometimes what happens if the DNA code is damaged, and that code, that gene, happens to be in charge of cell division and other things. We know that that cell can become, can start dividing, and then when it divides when it's not supposed to and starts spreading, that's what we call cancer, right? So if you can remember when we talked about that, we never talked about cell. The ways that we can address that. For example, cancer cells have this way of trying to evade T cells and other immune system cells. They'll even change the structure of their membrane, their outer membrane, and make it hard for the T cell, to focus in on the fact that that cell is actually sick and not doing so well. Brains, they change it, and these proteins are, I'll let you know, it's called MHC, but they change these proteins so that when the T cell comes along, it doesn't even know that it's sick. So what do you do when the T cell doesn't know how to do its job? What do you do when someone or something doesn't know? What do you do when something or someone doesn't know? Scientists figured out a way of doing just that. In today's assignment, you're going to be looking at a phenomenon. You're going to be looking into the world of biohacking, and there's a phenomenon that I have here. T cells are in charge of killing cancer cells in the body, but some cancer cells evade being detected by T cells, which are body defense cells. How do they do that? Okay, and I've talked about how the proteins change on the membrane. What I want you to do is, I want you to think and brainstorm. There's no right or wrong answers, but I want you to think and brainstorm on how you would solve that problem. If the T cell cannot detect the cancer cell, then how do you change that? How can you fix that? How do you do that when it doesn't know how to detect it? All right, after you do that, I want you to write in, you can either in the Google Docs or in the comments below, your ideas of how to change that, how to help the T cells identify cancer cells. And then I want you to look at the video, okay? And I want you to draw, after you look at the video, I'm putting that in the notes, I want you to draw the diagram that explains your idea after you look at the video. I want you to use some of the terminology you see in the vocabulary, like pathogens, cancerous cells, T cells, antigens, B cells, biohackers, CAR T cells, DNA, antibodies, chimera, and receptor. So you don't have to use all those vocabulary words, but in your drawing, you should have many of these ideas in your drawing. Again, there's no right or wrong answer. There's more or less you using your imagination based on what you've learned so far. Use your imagination. How do you get the T cells to be able to identify the cancer cells that have changed their cell membranes so that the T cells can't see them? And remember, cells interact using their cell membranes, right? So that's the way they can interact. And if that's something that the T cells can't see, that the cell's not doing so well and it's cancerous, that's a problem. Okay, so once you do that, go ahead and submit it. You can submit it to, you can actually keep it, submit the Google Doc in the comment section below. And so that way other students can see your ideas. Remember, this is not a right or wrong answer thing. This is you using your imagination, okay? All right. Have a good day in class. Mahalo.